Hi Professor, my name is Armin and today, together with my colleague Belmin, we are going to explain QFD or Quality Function Deployment and House of Quality. We had an exercise with drone, so I want you to introduce to our first step. So first step is called product planning. We managed to identify customer needs and then we started to prepare product planning matrix called House of Quality. First, I'm going to introduce you to customer requirements. First of them was payload, after that reliability, low cost, minimum flight altitude of 300 meters, good battery, maximum flight time over 30 minutes, obstacle detections with sensors, easy to operate, high quality camera and minimum speed over 30 kilometers per hour. After introducing customer requirements, I'm going to introduce our house, or how we call them, product design requirements. So there are a few of them, and let's start. First of them are motor power, then type of structure, sensor characteristics, propeller thrust, pixels value, battery capacity, and then materials. So also we found out that comparing different product design requirements and customer requirements, we can find out relationships between them. For example, comparing motor power to payload, we find out that between these two items there is a strong relationship, and so to reliability and structure, pixels to camera, flight time to battery capacity. Also, when it comes to comparing the weak relationship, we can compare easy to operate customer requirement with pixels value. That is important in RC drones, but not the one that we are currently making. Also, there are no relationship between some of requirements, like comparing high quality camera with motor power. Also, I must admit that we finished interactions between different product design requirements, but also we managed to get target values for different PDRs and the trade-offs at the roof of our house, what you can see right now. At the end of first phase, we searched and examined the market about our competition and find out two competitors, DJI drones and GoPro drones, and we already compared their products to ours.
After product planning phase, we go to second phase of QFD approach, which is called assembly or part deployment. The product requirements or technical characteristics defined in the product planning matrix are now listed down the left side of the deployment matrix along with priorities based on the product planning matrix importance ratings and target values. The deployment matrix is very similar to the product planning matrix. Technical characteristics defined in product planning phase, such as motor power, type of structure, sensor characteristics, and so on, are now translated into part or assembly characteristics. The concept of drone makes several main parts, like propellers, frame, motors, battery, camera, sensors, and so on. Characteristics listed at the top of the matrix are referred to frame and motor. Characteristics such as balance, lightweight, resistant to higher temperature, waterproof and shockproof are referred to frame, and characteristics like power and durability are referred to motor. Now you can see here relationships established between product requirements or technical characteristics and assembly or part characteristics. A circle with point inside represents a strong relationship between two characteristics. An empty circle represents a medium or moderate relationship between two characteristics, and a triangle represents weak relationship. In this project, weighting factor principle which is assigned is 931, which means that the circle with points inside has a value of 9, the empty circle value 3, and triangle has a value 1. Here you can see trade-offs or interactions between part or assembly characteristics. And at the bottom of the matrix, importance ratings are calculated and target values for each assembly or part characteristics that are established. When we calculate importance ratings, we have to multiply the technical importance ratings by the weighting factor in each box of the matrix and add the resulting products in each column. Just like in the first phase.
As we finish second phase, we can move to third phase. Third phase represents process planning and production planning for designing and manufacturing frame. For process planning and production, we have chosen FDM technologies, or so-called fused deposition modeling. FDM is capable of creating rapid prototypes. Only limit that we currently see is build volume of 3D printer. That is why we choose Ultimaker 3 Plus extended version with pretty high set build volume. So, our process steps are separated in a few stages. First of them represent creating 3D model in 3D modeling softwares like SolidWorks, CATIA, etc. And after that, exporting to readable format called STL. I say readable because of our next step called preparing model for 3D printing. In this phase, we need to slice model and get G-code. We do that by uploading model to slicing software, in this version Cura, and then exporting G-code to SD card or direct upload to 3D printing using USB cable. After that, we need to prepare filament. We are going to make frame from carbon fiber filament. This filament is ideal for anyone that desires a structural component with high modulus, excellent surface quality, dimensional stability, lightweight, and easy of printing. Lightweight plays a crucial role in our design, but also it results in more wear on your nozzle. So we are going to switch from brass nozzle to stainless steel one. Also, carbon fiber is resistant to much higher temperatures comparing to PLA and ABS and the other filaments. After preparing everything, last step before 3D printing is calibrating the 3D printer. We do that in few simple steps provided by Ultimaker. I must say Ultimaker 3 has an automatic calibration mode. So, next step, but not last, is 3D printing. After that, we have to do some surface finish for holes and clean up the support generated by 3D printer, and later assemble all components and finish everything with nano coating spray to reach waterproofness.
The last phase of quality function deployment is called process or quality control. In this phase, we have established process control methods as well as inspection and test methods. As you can see, we have determined a few control, inspection and test methods like visual inspection of drone components, lab testing for electronic components, performance testing, checking endurance and durability, and packaging inspection and testing. The first control process of visual inspection of drone components includes visual control of remote controller, lights, GPS sensor, camera, attachable wheels for ground use, propellers, landing gear, and others. The second control process is lab testing for electrical components such as the motor, trimmer, printed circuit board or PCB, electronic speed controller, ESC, and flight controller including gyro stabilization. Performance testing includes testing of headless mode and auto return home function. Then we have to check endurance and durability by measuring battery life and charge or discharge. And the last one, control process, is packaging inspection and testing, where we verify requirements for packaging markings and labeling, weights and dimensions. Now let's make a brief summary of QFD process for drone. So quality function deployment begins with product planning and continues with product design and process design and finishes with process control, quality control and testing. And QFD method is powerful methodology for planning a product like drone, and it reduces development time and costs in the process of drone production.